In this video, let us discuss about fundamentals of computing. What is a computer? A computer is an electronic device that processes data according to the instructions. Why do we need computers? We need computers to enhance efficiency, process information, automate tasks, and it facilitates communication and drive innovation across various domains. For this, to know about computers, how do they work and all, we look inside a typical computer. Inside a PC, we have power supply, 5.25 driveways, expansion slots, and 3.55 driveways. Power supply in a computer is responsible for converting alternating current from the wall outlet into direct current to power the internal components such as motherboard, CPU, GPU, storage devices, and peripherals. Simply, we can say AC to PC. Coming to the 5.25 driveways, in a computer, they are designed to accommodate optical drives such as CD or DVD drives, as well as certain types of front panel accessories like fan controllers or additional USB ports. Coming to the expansion slots in a computer are like empty sockets on the motherboard, where you can plug in extra parts like graphics cards or Wi-Fi adapters to upgrade or customize your computer. 3.55 driveways are also similar to 5.25 driveways. In these slots, we can install bigger storage devices like hard drives or SSDs to store our files and data. Now let's see the motherboard. Inside a motherboard, we have back panel connectors, CPU in CPU socket, memory in memory slots, expansion cards in PCI and PCIe slots, and storage drive connectors. Here is the main circuit board that holds all the important components and allows them to work together. On the motherboard, we have back panel connectors. These are the ports located at the rear of the case where we can plug in devices. We can plug in devices like monitors, keyboards, and USB devices and cables to connect them to the computer. Central processing unit. It fits into the CPU socket on the motherboard. It executes instructions and performs calculations to run the computer. Memory in memory slots. Memory slots are where you insert RAM modules in these memory slots. And these are essential for the computer's short-term memory, enabling it to store and access data quickly while the system is running. Expansion cards in PCI and PCL slots. They are the extra hardware components that you plug into PCL or PCLE slots on the motherboard to add features like graphics, sound, of or networking to your computer. Storage drive connectors are the slots or ports where we can plug in hard drives, SSDs, to store and access data on our computer. This simple flowchart tells us how the entire process occurs inside a computer. Functional units. Now, let us see how it works like a bus. A bus is used to facilitate the transfer of data between various components within the computer system. Serves as a communication pathway that allows the CPU, memory, and input-output devices to exchange data and commands. Central processing unit, it serves as the brain of the computer, executing instructions and performing calculations. It comprises of ALU, that is Automatic Logic Unit, for math operations, and Control Unit for managing various processes. RAM functions as the computer's quick access memory, temporary memory, losing data when powered off, while a hard disk, it is quite different from the RAM. It serves as a non-volatile long-term storage with slower access speeds but larger capacity. Memory, it acts as a fast access storage location holding data and instructions for quick retrieval by CPU. Input devices, keyboards, CD, and all, they are like ears and fingers helping us put information into the computer using the devices, input devices that I have mentioned. Now, output devices are like computers, arms, and voice of the computer. They show us information on the screen and print out what we need after the processing occurs. How a bus picks up people from one place and drops them at another place. It also takes input from the input devices and it does the process. It stores in the RAM or hard disk, depending upon the cases. It does the processing and then it drops the information onto the output devices onto the screen. Similarly, it works in this way. A computer knows only one language, and that language is called machine language, that is the binary language, the language that a computer knows. It consists of simply zeros and ones. In a computer, everything is stored in binary form, a sequence of zeros and ones. And it can only understand a binary format. For example, number 4 is stored as 00000100 and 1 is stored as this way. Now let us see the execution in a computer. To begin with, all the data and commands related to a computation is stored in a memory. Commands are then brought into the CPU through the bus one at a time. Each command is executed inside the CPU in the following. See, if the command requires data, it is brought to the CPU from the memory. Command is then executed using data. The memory, if the data is required to be processed, then the data in this memory is being brought to the CPU. And then it is executed using the data. The command may be for storing data present inside the CPU too. And we all know that a program is simply a collection of commands. And now let us see a small program. This is the binary format. It is a machine language which computer understands. It read the memory. The last 3 digits indicates the location. So location is 001 and this location is 010 and the rest of the part has certain value stored in it. And this is the function that does add the two numbers and the value is stored and the result is stored in the memory location 001. First value is 4 and the second one is 1. The 4 in binary format is stored in the location 001 and is sent to the CPU. That value is stored in that location. Similarly, the second value is also read and it is stored in the location 010 in the CPU. And now you can see that this statement is being executed. The two values are being added and the result is also sent to the CPU and the result is being stored in the location 001. This is how execution occurs in a CPU. As storing the data in this binary format and understanding it is a bit difficult. We have access to a language called assembly language. Assembly language is something that can be converted further into binary language. Binary language is called machine language. And to make it more readable, as we cannot understand binary language that fast, assembly language was introduced. In assembly language, operations and memory locations are addressed by names, but not through a binary format. The locations are named as num1 and num2 in assembly language, as you can see, and in CPU as R1 and R2. This statement in binary format is in this way in assembly language. Move the num1 in memory to R1 as R in R1 location in CPU. The same for the second number, and this we have already seen that this adds the both values, and in assembly language it is simply stated as add R1 and R2. R1 and R2 has the values num1 and num2 in CPU. Now the result is being stored in the location num1 or R1 in CPU. See, move the contents of R1 to the memory location num1. An assembler is simply a system software. It eventually must be translated to a machine language. Assembly language needs to be translated, and an assembler does this job. It maps the names to the corresponding binary values. It is also a program. Assembly language being translated to a machine language. Assembly language is converted to a machine language, and this is being done simply by assembler. See what is an operating system. The above example only shows how to add numbers already present in the. How does one add numbers provided by the user through the keyboard? See, this is the job of another program called operating system, which is simply called as OS in short. And OS, it picks the input given by the user and stores it in appropriate locations of the memory. It also picks results of computations from memory and displays to the user. Does many other housekeeping jobs that make the interaction of the user with computer easy. And certain examples are Linux, Windows, Mac. It is very difficult to write large programs in assembly language. So in the era 1960 to 80, simplify this task. They invented high-level programming languages like COBOL, Fortran, Pascal, and C. In operate the OS that use Windows and all have C programming already for their functioning are low-level programming languages. Now let us see a simple basic C program. But C, this program int main denotes the beginning and the end of the program. In C, num1 and num2, as we have seen in the functional units, how a memory location is named. This is the way we name a memory location for num1 and 2. Get int, it reads a number from the input and stores it in specified memory location. This involves the operation of OS. In C, we generally use scanf function and hash include. In this, we use stdio.h. That's a library, includes the functions printer, scanf, and all. And this adds two numbers and stores the result in location number 1. It corresponds to the whole machine language program earlier. This is a format specifier. And even for after the functioning is done to show it on the screen, this also involves OS to do it. And return 0 indicates that the program has been executed successfully. And as we have seen that assembler is used, does the operation to convert assembly language to machine language. Compiler translates a C program to machine language. There are many C compilers like Turbo C and all. We use one called CLAN. This is a basic introduction about computing.
Let us see the steps involved in debugging a sample C program. Now here we have to add breakpoints by clicking at the left side beside the number to add breakpoint. Now click F5 on the keyboard to start debugging. You will see variables a, b and sum on the left side that you have defined in the code. Now b is already given 4096, that is the garbage value which is already predefined before. Now click on continue. The next line will be red. Now you have to give the values of a and b as well. You can observe by entering a number, that value is stored in the variable a. See, you can see. And now if you click on the continue again, and next line will be red. Now you will be asked to enter second number. You can enter. Then you can see that the value of the b has been changed. Now b is assigned with number 3. Now the sum is been got displayed on the screen.